Hello. Welcome to Picture Me Coding with Eric Aker and Mike Mull. Hi, Mike.
Hey there.
Mike, you have a larger volume of birdsong behind you today. It's pretty pleasant. Summer bird songs.
Interesting. I am in a different room than normal and a window is probably open. I hope people
I
like bird songs.
I bet people like bird songs in the back of their podcasts. I bet I would, although I don't know if I've heard many podcasts where people are talking and there's birds singing behind them. I wanted to mention something right off the top here. Now, Mike and I, we have been very busy the last couple of weeks. We both have jobs in addition to this show. This show is a hobby for us. And for both of us, the work environment has become quite exhaustingly busy lately. As a result, we're going to start doing this show every 2 weeks. We're going to release one every 2 weeks. Instead of every week, you may have already noticed we've been a little slower on the cadence. So apologize for not announcing this earlier. But Mike, I have a question for you. If we do it every 2 weeks, is that bi-weekly or bi-monthly?
I believe it is bi weekly and semi monthly.
Okay, bi-weekly. So bi-weekly is our new intended publishing schedule for this show. So if you are looking forward to hearing us every week, unfortunately, we are not going to be able to keep that up over the next, probably at least the next 6 months. But we do appreciate you listeners. We appreciate you checking out the show and reviewing it and commenting on it and telling your friends about it. If you like the show, we have Patreon subscriptions available where you can support what we're doing for $4 a month, the cost of a cup of coffee. You can actually send some support to the show and help us pay for our hosting costs, which are not too expensive. And that's why we have really just a $4 a month support membership level. Thanks so much again. So, Mike, I have told you recently about a record that I don't think my interest in it approaches obsession level, but I love it and I can't stop listening to it. And I can't remember another record I've heard this year that I love this much. This is actually a record called La Fondar by the artist Heems. I'm pretty sure I made you listen to this. I made you listen to this, right?
You sent me a song and I ended up listening to it, and I also like it.
I love this record. There's so much funny, clever stuff on it. There is a cultural feel that is not common, I think, in hip hop from this country. There's Bollywood references and references to culture in India and all kinds of stuff. There's some great lines on it. There's a song called Yellow Chakra where he raps, "I'm like a city during COVID, said my bar's infectious." I really like that line. That's pretty good. And then actually on that same song, Open Mike Eagle's on it, and he says, "I'm track 3 from It Was Written," and I was like, "Whoa, this is giving me goosebumps hearing it." That's my one of my favorite songs, and that's like quite a flex to claim that you are that song. Like what a bold hip hop claim. I've never heard a flex this bold. I don't think
It's a good one.
it's bitchin'. And then there's a song called Porches, which I think is my favorite one. And it's very like clear sounding. It reminds me of 90s hip hop, like just this crystal clear sounding message from out there in the world. And then finally, there's a song called Bukayo Saka. And he talks about the Mahabharata. And then he says this hilarious thing. He says, "I roll around with two glizzies like I'm Slavoj Žižek." I've never heard glizzies before, but apparently that's a word for hot dogs. Slavoj Žižek is his cultural critic. I think he's Slovenian. And he's notorious for saying weird, out there stuff that's hard to follow. And just always, anytime there's some cultural moment, he's just off to the sidelines, just saying his weird culture critic stuff. So he kind of became a little bit of a meme on the internet. And apparently, there's a video of him walking down a street in New York, just greedily eating two hot dogs, one in each hand. So this line is, I roll around with two glizzies like I'm Slavoj Žižek. There's so much that makes me laugh on this record, and the music is so good. So if you like hip hop, you got to check it out. Heems, La Fondar.
Yeah, I enjoyed it too. Ironically or coincidentally, I'm not sure what the appropriate word is, but it's been a while since I've heard a rap album that I really liked. And
Mm-hmm.
by a weird coincidence, my pick this week is also a rap album. It's one that I somehow missed. It came out back in March. It's called From the Private Collection of Saba and No ID.
Oh, I liked that first album by Saba. I liked.
Yeah, I like a lot of his stuff. and No Idea as well. She's had a couple of excellent albums, and they're both from Chicago and are sort of affiliated, and not surprisingly from the title of this album. This is mostly Saba rapping, but it's just it's interesting both musically and lyrically. Just kind of like your choice this week. There's a lot of interesting lyrics on here, which unfortunately I can't quote because they are not podcast appropriate. But but yeah, I really enjoy this. It's one of those that you can just listen to over and over again and pick up new stuff, and it's got quite a bit of variety on it, and quite a few interesting collaborations and so forth. So yeah, give it a listen.
I feel like we're trading hip hop records this week. I really like that. We're meeting up. We're in front of the record store, and I'm shoving one in your hand, and you're shoving one in my hand. And I can't wait to go home and hear it. Although
Yeah,
I am home.
I think you will like this one. I would be very surprised if you heard this and decided that it was not a worthy recommendation.
I'm eager to check it out. Last time we met, we discussed the career of Jim Gray, and I actually really enjoyed that discussion. I mean, I enjoy our discussions usually. That's why I enjoy doing the show so much with you. But I learned a lot about Jim Gray, and I was really impressed about his career. And I wanted to continue the discussion with you about the history of databases. Databases are ubiquitous in our work, and I feel like they're a tool that I don't think too much about the history of. They're just a thing that I use as if they were always there. And that's another thing I like hearing about your perspective and your experience, because when I talk to you, I remember, oh, yeah, they weren't always there. They weren't always this tool that everybody just used for all of their problems. So this week, we're going to continue our discussion about relational databases, history of relational databases, moving on from the work of Jim Gray and talking more about where the relational databases we use on a day-to-day basis, where those came from and what their history was. Does that sound good to you?
It does. I thought maybe also we could make an attempt to sort of define what a database is. We made a sort of vague attempt at that in the last episode, but I thought maybe I looked up a few definitions from various vendors that
Hmm.
I thought maybe we could mention.
Okay, well, I don't want to do that, but I would be happy to sit back and listen to you do it.
All righty. So, like Eric said, we're going to talk about relational databases this week, but first of all, let's talk about what a database is in general to sort of distinguish it from the notes that you keep in your editor and stuff like that.
Or the thing you're going to hiss at, my Excel spreadsheet, Mike.
Yeah, first of all, I suppose we should also mention that, people typically use the word database to mean like the actual data. IMDb is a database of movie information. We sort of informally use the term to also mean the database management system. Hopefully, it will be clear from context, but a lot of times when we say database, what we really mean is database management system.
Yeah, actually, I'm a little fuzzy on that. Why are you making that distinction? Like, I have a table in a database. Where do I apply the word database? Where am I applying it wrong? I say database is a collection of tables, but you're saying that's a database management system?
Well, I just think that a lot of people, when they hear the term database, especially if they don't work in the field, they probably think of a collection of data related to a certain thing, health database or a protein database, or like I said, a movie database or something.
Hmm.
And the thing that we're going to talk about this week in particular is sort of formally called a relational database management system. Very often, people in our profession would just say, "Hey, what database are you using?"
Hmm.
And what they mean is the actual management system.
Well, I guess I've seen the acronym RDBMS a lot, but I never even think about the MS.
And the term is kind of fuzzy. So
Oh,
I just want to make clear for people who are not full-time professional programmers that we do use the term database informally to mean the database management system, if that
all
makes
right, all
sense.
right. I don't know if I'm making any progress on understanding, but let's just keep going. We'll just charge blindly ahead. I don't understand. Let's move on.
Interestingly, a lot of these definitions use the more informal language. So, anyway, from an IBM website, a database is a digital repository for storing, managing, and securing organized collections of data.
Okay, storing, managing, and securing Organized collections. That's a pretty basic definition that I can get behind that one. That makes sense to me.
Here's a much more complicated one from AWS.
Oh.
A database is an electronically stored systematic collection of data. It can contain any type of data, including words, numbers, images, videos, and files. You can use software called a database management system to store, retrieve, and edit data. In computer systems, the word database can also refer to any DBMS, to the database system, or to an application associated with the database.
Hmm. Okay. Systematic is the word that jumps out to me there. Systematic collection of data. They apparently haven't seen the databases I've worked on.
Yeah, fair enough.
But to an application, you could call the database an application associated with the database. You would call it that. That sounds a little weird to me. No need to pick nits on that particular. That's just weird. I'm not sure. I like the IBM definition a little better so far. I'm storing, managing, securing junk.
Here's one from the Mongo website.
Oh, are they
Formerly,
are they a little biased though? The Mongo site.
probably, yeah.
Okay, all right. I won't. I'll stop throwing
I
rocks at it.
Mongo is not a relational database system, so maybe this is a little skewed. But formally, a database is an organized collection of structured or unstructured information stored electronically on a machine locally or in the cloud. Databases are managed using a database management system. The DBMS acts as an interface between the end user and the database. Databases use a query language for storing or retrieving data.
I like this better than the AWS one, but I'm not sure what I'm really getting out of the distinction between a database and a DBMS, like a database management system. I've got a bunch of databases on one server. I want to manage them. The MS, I just feel like is kind of meaningless to me. Is are we? I don't know. Am I being too naive?
Well,
Do I need to
here's
care about the MS?
here's what I'm thinking. Suppose that you're like are a hobbyist who is into art or something like that, and
Hmm.
so as you're clicking around on the internet, you see images of paintings from the 19th century, which is your particular thing, and so you store them on your hard disk locally. So you have this collection of files in a folder. It would be reasonably legitimate to say you have a database of images of art.
Oh, okay. So we
However,
add the MS because the term database is kind of overloaded.
right, and there's certain things that you're missing with your file collection. In other words, there's no metadata that identifies who the artist is and what the painting is necessarily. You
Hmm.
might have to open up that file and look at it to determine who the artist is for that painting.
This
So
this might annoy people listening to us, but the MS just feels kind of pedantic to me.
it's a vague term, I think, maybe intentionally,
All right, I'll
but
stop. I'll stop fighting it. I'll just accept it. We're talking about our DBMSs, relational today, not even just DBMSs, right? Relational
right.
DBMSs.
And so, what makes something relational is, I guess, the next topic of discussion.
Okay, so what's a relational database? Well, now I think these are terms, of course, that a lot of our listeners are going to know. They're going to at least have examples come to mind for relational databases: Oracle, MySQL, PostgreSQL. We've talked about Postgres a lot on the show. We talked about Jim Gray's work and refer to databases a lot. When you first started working with databases, were they always relational databases, or did you work with other weird things? Maybe I'm already biasing it, prejudicing the answer by throwing in that adjective weird.
Yes and no. And this kind of goes back to the weird language. So, the first database management systems that I encountered were relational. I did not have any experience with the things that came before them, which is why we're not talking much about them. And
Mm-hmm.
I did not, until much later, have experience with the things that came after relational systems. I did have exposure to things that were called databases, but did not necessarily have this type of management system.
Okay, I'm starting to get where the pedantry comes from. This is an old guy thing. This is a hey kids, we used to call this a database too. Okay.
So, for instance, there was and still is a well-known thing called the PDB, or the protein database,
Oh,
which was a
I thought that was a Python debugger.
it might also be that.
Yeah.
But back in the 80s when I started out, I was working with people who were interested in proteins, and there was this file format called PDB, and it was a format that would give you information on a particular protein,
Hmm.
the amino acid sequence and that kind of thing.
Mm-hmm. Mm-hmm.
And but it was not a relational database system. It was not a formal database management system. You had a tool where you could sort of search the database a little bit, but
Okay.
it was not a relational database.
Okay. So
Anyway,
like object storage, like blob storage in Azure, cloud storage, file storage, Google, right?
yeah.
S3.
So what you would get out of it was basically a file,
So
and
S3 is not a relational. Well, obviously not relational. It's not a database management system. You could search by prefixes, but that's not a database management system.
yeah, that's a good analogy. Is like most people, if they work in this field, probably are familiar with S3 and other types of object storage, and those are big systems that store data, but they are not database management systems.
Even the
So
10 nines, you would think that after enough nines, you could just call it whatever you want.
that's true.
Oh,
Yeah,
okay.
when you
So your
so
first
anyway,
relational database then? What was the first one that you dealt with that was relational?
so the first relational database that I encountered, which is kind of surprising, is was Postgres. Um,
Wow. What time would that have been, do you think?
so this was early '90s. Postgres was still fairly new,
I thought it
and
was created in the 90s. Is that not right? We're getting this later probably, huh? When was it created?
so officially started in 1986.
Oh, okay.
And
Okay.
we will talk about this a little bit more later. But so I kind of vaguely mentioned in the last episode that I was involved briefly on this thing called Sequoia 2000. This was a project that was started in the 1990s with the objective of reaching certain milestones by the year 2000, because that was way back then still a thing in the future. One of the things that I and my boss were trying to do was demonstrate that you could store protein data in a relational database.
Hmm.
And one of the participants in that project was also Berkeley, so University of California, Berkeley, which is
Mm-hmm.
where Michael Stonebreaker, the creator, one of the creators of Postgres, was working.
Yeah, and you were like on email threads with him, I remember you saying.
That's right. Yeah, we got into a flame war on an email thread. Um, but so it was a relational database. It taken ideas from its predecessor, which was called Ingress, which we will also talk about later. But he was also he was trying to add features to it that looked kind of object oriented, because that was
Hmm.
kind of in vogue at the time, was this idea of object oriented databases. So he called it a relational object database, and the idea was that you could have some sort of OO features, but in this underlying relational model.
Hmm.
So it would have things like fields that could compute things from other fields,
Hmm.
or fields that kind of did implicit joins to other data and that kind of thing.
Okay, that's pretty interesting. So you could do like almost like you could imagine what the equivalent of a dotted lookup of an attribute would be, and below that is a computation.
Yeah, exactly.
That's pretty
And
cool.
yeah, and it didn't really persist in Postgres, but it was a nice idea. And so, we were trying to use Postgres because it was his research project, and we were doing this research project, and it seemed like it might be a good fit. And so, yeah, so in a sort of weird coincidence, I had access to Postgres long before it became a common thing. In
That's rad. So when recruiters reach out and they're like, I need someone with 30 years of PostgreSQL experience, you can be like, I am one of a dozen people with 30 years of PostgreSQL experience.
That's right.
But you didn't use it for a long time, right? But you just used it in that one project, and then you probably used other databases after that and at work in
Yeah,
the 90s.
used that used that for a while, and then when that project ended, I was exposed to a few different types of database systems, but probably by the late '90s, the main thing I was using was Oracle.
Oh,
Oracle was definitely at that time sort of the 800-pound gorilla of the relational database market, and
are you kind of shamed now that used Oracle, knowing how much Jim Gray hated Larry Ellison?
a
That's a
little
weird
bit,
reference.
yeah.
Weird reference right there.
Oracle was the database that I was using in the late '90s to early 2000s to work on various what we called informatics projects back in the day.
I remember that word. You still see it in academic in curricula
Yeah, I think it's more
and
common in
bioinformatics, I
Europe.
guess.
I
Oh,
think
okay, okay.
in Europe that's kind of what they call computer science, as I understand it. But
So I kind of got you off track a little bit. You want to talk about history of these, or do we still need to define our terms? We talk about databases, database management systems. Do we need to talk about what's a relational database?
yeah, I think we should talk a little bit about what we mean by that term.
Relational.
Yeah, I mean, a lot of people probably know, but we should probably make an attempt at formalizing it and defining it.
Okay. All right. Go ahead.
We mentioned last time when we were talking about Jim Gray that he worked for a guy named E.F. Codd in the System R group at IBM.
Hmm.
And Codd wrote this extremely influential paper in 1970, which kind of laid out the ideas of relational databases and what would be called relational algebra. Paper was called, let me see if I have it, A Relational Model of Data for Large Shared Data Banks.
Yeah, I haven't read this, but I kind of want to read it because every time you start looking at the history of databases, everybody talks about this paper.
Yeah, I mean it's a pretty famous paper, and Codd is sort of almost synonymous now with the idea of relational algebra. But anyway, the idea was that data is stored as what he called relations, a relation in the mathematical sense. So, if you've taken like set theory, you've probably come across the term relation, and mostly you'll see binary relations like greater than or less than, things like that, where you have one set on the left side that's related to a set on the right side. In Codd's formulation, these relations are generally not binary, not exclusively binary, so they are n-ary relationships.
So it could
And
be N-ary. So that means binary is is like I've got a thing on the left and a thing on the right. But in this case, we can have a lot of different so-called. Maybe we'll think of them as arguments for functions in a way.
right, and you can also think of them as he does as being like the cross product of a series of sets, and you're
Hmm.
looking at choosing one thing from the first set and one thing from the second set and one thing from the third set and so forth.
Hmm. Did is sequel comes from that paper, or was that a related thing that he talked about at the time?
So the idea of those of the manipulations that SQL can do, and the idea of having a particular special language for doing it, kind of comes from Codd's paper.
Got it.
But
Right. Okay.
the actual language would come from some other guys a couple of years later. So anyway, relations in sort of informal terms are what we now think of as tables.
Hmm.
So, the relational database is the sort of key elements are tables with rows and columns.
But they can be they can be tied to each other in a way or linked to each other, and
Yeah, and
that's a
so
relation.
you can have, well,
And they can be tied to themselves.
so
Am I muddying this already?
the relationship between tables is different than the relation. So
Okay.
the relation is entirely encompassed within a single table.
Data that's related it
So yeah,
inheres.
so a row of a database is one element of an n-ary relationship, or sorry, an n-ary relation.
Okay. Oh,
I'm trying not to use the word
okay.
relationship.
This makes sense. I think I lean too much on my fuzzy working knowledge of these tools to when I you start applying more formal language to them and I kind of go, yeah, 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 that makes sense, but then go right back to my like lazy workaday understanding of the relational database.
So some aspects of this are that the you have a table with a bunch of rows, and the ordering of the rows doesn't really
Mm,
matter when you get down to the level of the actual code and the computer hardware and stuff. The ordering of the rows might have some effect on performance, but conceptually, the order of the rows doesn't matter. Sometimes the
mm-hmm.
order of the columns does matter, though. In particular, every row has to have the same ordering of columns.
Okay.
And another important thing of this is that there's typically some subset of the columns that is unique across all rows. In other words, that group of fields is unique and for that row, for every row in the table, and that's called a primary key.
Hmm.
Codd went on to define sort of the operations that you could perform on tables, and this includes things that we think of now as being pretty common, like projection and joins and so forth. So,
Yeah, when I first learned SQL, I had a class. I don't remember where it was, but I could have sworn in that class they said this language SQL comes from sequent calculus. That might not even be right. And they started talking about selection, projection, and was it joins? Was it the third thing? There were three things: selection, projection, and
yeah,
I thought it was join.
selection
Maybe I'm
and
wrong there.
projection are roughly the same thing. Joins is definitely one of the things in there.
Oh,
And yeah,
okay. All right.
as we
All
know,
right.
there are
All right.
multiple types of joins. Cod
Mm-hmm.
also talks about what he calls restriction, which is what we would think of as being, filtering or the predicates in the where clause.
Oh, okay. So you could think of it like a giant Venn diagram, right? And you could just keep adding more circles, and then really what you're looking for is slices of the Venn. I mean, often the way people teach joins when they're just kind of visually trying to get people who are new to writing SQL to understand what they're doing or how to query databases is they'll use Venn diagrams: left join, right join, full outer
Yeah,
join, inner join on. That Venn diagram metaphor is really useful for this. But thinking in terms of sets is also useful. Set intersection, set difference,
right.
etc.
So some people call this relational algebra or Cod algebra, but it's really fundamentally sort of based on set theory. And
Hmm.
you can sort of think of a lot of queries that you can form in SQL as being, equivalent to defining a set. So another thing that we're sort of glossing over here is that SQL does have sort of multiple parts. So there's the querying part, but there's also typically some sort of data definition language. So you can define tables and define indexes on tables and that kind of thing.
So you may have a whole bunch of rows, which are just ordered tuples of data, for example, in the actual implementation. But we're naming those two. We're naming the index of the tuple as a particular column with a particular data type, and that data type is consistent
Right. Yeah.
for all rows.
Um, as you also implied earlier, that you can have sort of complex data by having tables that are related to each other. And this is complication in the language here.
Yeah, you were like, "That's a relationship, not a relation, my friend." And I was like, "Look, I'm still learning the world of relationships. Okay, there's still mystery to me."
So one or more fields in one table can constitute what they call a foreign key, which is actually a key into another table. And one of the things that Cod also defined in this paper, which is now a fundamental part of relational databases, is what he called normal form. That's in
That's
this
in this
paper
paper.
as well. Yeah.
Oh, I had
So
no
the idea
idea.
here is that you want to structure your tables in such a way that you don't repeat too much data. A lot of times you'll hear now people talking about you want to achieve third normal form.
Third normal
Uh,
form, yeah. Now, friends, if you're listening to us and you want to go to work and make your coworkers feel bad, this is one thing you can talk about. You could talk about normal. If you never heard of normal form, you look it up and then you go to work and you say, look at our databases. We're repeating ourselves a lot. We should be more normalized. What are we doing? This is shameful, repeating ourselves so much. And you could use this term, you could use this concept of normal form to make people feel bad about how they're organizing their data. That's how it was used on
yeah.
me anyway.
Uh,
In the very early days of my career as a cudgel.
and
You're doing a bad job.
in most organizations, there's almost a guarantee that you will be violating third normal form somewhere in your database.
I, I think there was somebody at work one time, at least 10, 12 years ago, where we had one of those kind of database critics who was like, no, this is not normalized enough. We should be going for third normal form. And somebody who knew what they were talking about stood up and was like, that's not going to happen. It's virtually impossible. Leave us alone. Stop trying to make us
I
feel
was in a
bad.
meeting once where we were talking about, what was our database in third normal form. And this one guy kind of sat back in his chair and he said, I think we should try to get to fourth normal form. And everybody just kind of went silent. And I still to this day don't know if that's a thing or not. But
Oh, yeah, I thought it goes
yeah,
up to
I think there
fifth,
are
third,
higher
fourth, and
levels of
fifth.
normalization. But anyway, the idea is that, you don't want to repeat data in tables. So, for example, a common thing would be is if you have let's say a person's address. So
Yeah, I was going to go address
Yeah.
example. Yep, that's what I was going to do. And then I was going to take shots at this example. Let's go for it, though. This is the one I
Yeah. So,
remember.
it's kind of a classic case is, an address consists of all these multiple parts. There's a,
Let's just do US and Canadian
right.
addresses. Usually a
There's a
number, a
street number
street,
and a street and
maybe,
a zip code and maybe an apartment number. And,
yeah, sweet. A
uh,
city and a state and a zip code or a postal code. That's
right.
pretty
So you're going to have a
standard.
number of,
But wait, Mike, you and I might live on the same street. What if your street address is in the database and my street address is in the database? Have we duplicated something because that's the same
yeah,
street? You're
got to
laughing.
pull that out into a separate table so you don't duplicate street name.
It's not third normal form unless you put that street in its own table and reference it from our addresses, right? Sorry, I'm already like taking huge swings at this design.
So this is probably like more taken considerably more seriously back in the days when they were defining this stuff. I mean, it is important. Don't get us wrong.
Oh yeah, I'm not making fun of it. It was just that I worked at a place where people were like, "No, we need to put all the addresses in this table, and the addresses need to be normalized." And we were like, "Why?" And they're like, "So we could figure out if people are close to each other." And I remember feeling at the time like that sounds very complicated. Don't we have a simpler way of figuring out if people are close to each other, like lad and long or something? I don't know. Like, there's got to be an easier way to do that. You really want me to join all these tables to assemble a single address? Sorry, I'm fighting battles from 10 years ago. You could see the wounds are still
Well,
fresh,
back in
Mike.
1970, when Cod wrote this paper, they were the storage medium was potentially like tape or something like that.
Tapes.
So
Yeah,
the idea of
exactly. Yeah.
making the database as minimal as possible was probably important.
All right. I should let that. I'll let that go. It's okay. It's in the past. I forgive those people. I forgive myself. Let's heal and come together. Put all the data in one table, right? I don't need relations.
Yeah, and something that I got very good at over the years was denormalization.
Hmm. You got good at
Yeah,
duplicating stuff.
sometimes it's useful to make things faster.
I feel like we're going off track here as we're fighting these old battles. You sent me an interview with Michael Stonebreaker, and I enjoyed it quite a lot. The interview was from maybe 2014 or something like that. He had won a Turing Award, and he talks about the history of databases. He says in the 1970s, there was only one database market, basically business data processing. And the whole goal of data management was to make business databases work better. Relational databases were originally designed with that goal in mind, and that was the only market anyone really saw until 1990. Then I think over the next 15 years, it occurred to most everybody that they needed a database system. I didn't realize this. It's just like, yeah, we were just doing some dumb business stuff.
In the days when they were defining this stuff, it was business applications, accounts and inventories, and primarily in businesses that could afford the relatively expensive computers that you needed to run these things on. Now it's just kind of amazing how pervasive these things are. At this point in time in 2025, relational databases are not the only choice anymore, but there's still
Mm-hmm.
major products like Oracle, MySQL, SQL Server from Microsoft, Postgres, and then all the cloud providers.
Specialized
Yeah,
cloud offerings. Sorry, yeah, you
AWS
were going
and
to say that.
Google and Azure all provide managed versions of MySQL and managed versions of Postgres and Oracle sometimes and things like
PostgreSQL,
that.
yeah.
I saw something that
Mm-hmm.
said that the
Mm-hmm.
the market for relational database software as of 2024 was almost $22 billion, and about uh,
Wow.
MySQL still has the biggest share of that.
Oh, wow. I'm actually surprised to hear that.
I was too.
What's the market what's the market share percent that they gave?
The thing I found said MySQL has 41% of the market share, which I was surprised by, but I think maybe it's because it's kind of built into a lot of things.
Oh, okay. So 41. Well, it's sort of baked into WordPress, and WordPress has a pretty dominant presence on the web still.
Yeah, I mean stuff that I think of as being sort of old now, like
Hmm.
Drupal,
Mm-hmm.
largely based on
Yeah, that makes
MySQL. But
sense. Well, so do you have any idea? I mean, there were all these non-relational databases, NewSQL, NoSQL, people called it for a while. You talk about Mongo, for their definition, Elasticsearch. Is that stuff eating into relational database market share, you think? Or is there still, I mean, I would imagine that most people build an app, they're going to start on relational databases. Do you think that's correct, that gut response?
I think it's still very common for people to sort of immediately reach for Postgres and MySQL, and especially the cloud versions of those. I think
Hmm.
it's, we will talk about different styles of databases in future episodes, but I do think it's probably more common now for people to, for certain types of web apps, people are probably looking at things like Mongo and Firebase and DynamoDB.
Dynamo,
Yeah.
Cosmos DB on Azure, yeah. I was curious if you go back to this Stonebreaker interview. Stonebreaker, by the way, I'd never seen a picture of him. When I think the name Michael Stonebreaker, I think of like a spy, like a really fit guy who can run fast and jump out of planes. And that's not really what the image I got when I saw. Anyway, that's probably not a really fair comment. But I read this interview with him that you sent me, and I was like, I can't believe Mike argued with this guy. This guy's amazing.
Yeah. If you didn't hear in previous episodes, I lost an email argument with Michael Stonebreaker back in the 1990s. So,
So he brings up something that also came up when we talked about Jim Gray, that when Cod wrote this paper in the 70s talking about how you should view data as tables, right? Actually, let me just read to you a quote from the Stonebreaker interview. This is Michael Stonebreaker says, Ted Codd wrote his pioneering paper in 1970 that said you should view data management as tables, the simplest possible data structure, and then access them in a high level language. Now that means SQL. These were revolutionary thoughts at the time and went counter to all the existing data management systems. Immediately, there was a huge debate between the relational folks who said Ted Codd's ideas looked great and the traditionalists who said you can't possibly build one of these to be efficient. And even if you could, no one could understand these newfangled languages. Now, I thought that was a really interesting quote. There's a few things that jumped out to me there. But Jim Gray also made this same comment that when Codd had these ideas, there were these critics who were like, no, 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 that's never going to be efficient. It's not going to work. And I would be curious. I don't think we know. I mean, I don't know if you know, but I don't know what the argument is about why it wouldn't be efficient. I'd be curious what that argument was. Do you want to try to take a stab at that? It's okay if you don't.
I think it would be, I think I would have to go back and look through the literature to see what people were addressing. But I think one thing that sort of comes to mind is that, because I did encounter this in some contexts back in the good old days. So the databases that came before relational databases, and we mentioned these a little bit in the Jim Gray episode, there were two styles. One that was called network databases that were largely the work of a guy named Charles Bachman, and then there
Mm,
was what they were called hierarchical databases. I think that one issue that people immediately had with the relational model was we're storing things that are really complex. Sometimes we have very simple data, which is just a simple row of some item that we sell or something like
mm,
that.
mm,
But
mm,
inevitably, these things turn complex, and there's relationships between things. And so the approach that the network databases had taken, and the hierarchical database as well, was that when I have these multi-part things, I'm going to just literally make a connection between the larger parts and the smaller parts. And so when I want to look up all the parts that I need to make some larger thing, all that's immediately there. Whereas with the relational model, you have to have this underlying code that looks in one table, then
yeah.
finds the right keys, goes to another table, loads that up, and
Mm.
matches them together. And I think at the time, especially with the hardware that people were dealing with in the early 70s, that probably seemed like a really hard problem to solve efficiently.
Oh, yeah. They're imagining sequential scans over everything, all data, all the time. Every time you run a query, you're going to do a sequential scan, maybe is what they're imagining.
I think that's part of it. Yeah. Yeah. And just, the you couldn't easily go from the top of the hierarchy to the bottom of the hierarchy without doing,
Hmm.
joins and joins and
I
filters
guess
and so
it's
forth.
interesting to me too that databases become so ubiquitous. There was this critique of the relational model idea. Hey, this is not going to be efficient, but people charged forward anyway and said these ideas are great. Let's try them, and they built the stuff, and it ended up working and succeeding. I mean, by any measure, it's a success. I just kind of thought it's sort of easy to sit back. No, that's not to take shots at those people either, but it's sort of easy to sit back and go, "Oh, that'll never work. It will never be efficient." And we're sort of fortunate that people didn't go, "Oh, you're right." We'll give up on this idea.
I think also we are a little bit spoiled in
Oh, because of
2025.
stuff got faster and Skynet was supposed to happen in 2025, but it didn't actually.
If you think about how people actually use databases, it's relatively simple in most cases. Sometimes people may not even be aware that they're doing SQL. A lot of systems now, a lot of programming language constructs now exist to do queries on databases that make things look like objects. There's the object relational management system, ORM systems that make access to a database look like objects. And there's various other things in certain languages to sort of abstract over SQL. But even if you're doing SQL, you may be doing a join across a table or two and selecting some fields from those tables. You don't have to think about what's happening inside that query, but there's
Hmm.
just a huge amount of work that's gone
Yeah.
into,
Yeah.
you know, looking at that query, optimizing that query,
Hmm.
doing various things to make, once the query planner has figured out what to do, there's various things that have made those operations much faster than they were originally. Also computers have just gotten ridiculously
Yeah.
fast. So
Yeah. I guess you could look at that problem and go, "Oh, they'll never be able to figure out how to magically optimize queries, arbitrary queries that people are submitting." For one other quote I had from that Stonebreaker interview, he talked about the origin of PostgreSQL, and he said that this people critique they critique the idea that it was going to be inefficient, but we built these things, and then we had like Ingress, and we had System R. System R, that's the IBM one, right? That Jim Gray worked on.
yeah,
Yeah, and so from Ingress, the reason they came up with PostgreSQL, maybe I had heard this before, but I don't remember it ever being expressed so like as such an obvious reason or immediate goal. But Stonebreaker said to the first approximation, relational databases fell on their face when you tried to apply them in different areas. So it's not that they were inefficient, it's just that you couldn't easily use them in other areas. The problem wasn't the relational model, he says. It was more the data types that Ingress and System R supported were floats, integers, character strings, money, and that's what the business people wanted. But if you wanted to build a geographic information system, you want points, lines, polygons, that sort of stuff. He gives that as an example of like you could put arbitrary stuff in today's databases, you couldn't at the time. He says, so one of the basic ideas in Postgres was let the user have whatever basic data types he wants to manage and don't predefine them by insisting they be the ones that apply to business data processing. I thought this was actually a pretty cool distillation of the reason for them creating Postgres, the reason why. I didn't know this. Did you know this was the reason why they made it?
I did not know it was the motivating factor. I did know that stuff existed because of my early exposure to Postgres. That the idea that you could have a field that was essentially like a structure in a programming language was very unusual at that time.
Hmm.
So
Sounds like a nightmare to support that too. Can you imagine the bug reports they must have gotten in the beginning?
yeah, I think it was, and like one of the issues that I discovered with it, and that was part of the argument I've referenced a few times, is that there were cases when you wanted to define a data type, and the only way to make the database support it was to write your own code in C and link it into the
Oh, wow.
database. So, there were cases where not only was this idea of supporting new data types difficult for the creators of the database, it was also difficult for the users of the database.
So I jumped ahead to PostgreSQL. We talked about Jim Gray a little bit and IBM and System R, but there's a lot of pieces missing from this story, I think. Yeah.
Right. So, we talked about System R and Jim Gray, and then Ingress, which was Michael Stonebreaker's first relational database product, which he developed at Berkeley, was followed right on the heels of that. They were apparently reading the papers, and in addition to that, there were a couple of guys who were reading the paper and heard about these ideas of having a language to query the database. And so a couple of guys, Chamberlain and Boyce, started to develop languages for querying relational databases, and they eventually hit upon what we now call
Oh,
SQL or SQL.
oh, those are the SQL. I always thought COD was the originator of SQL. That's not right then. He just said we need a language.
He invented sort of the idea that they were working
Mm-hmm,
from.
mm-hmm,
They went
mm-hmm.
through a couple of iterations of languages to query databases and eventually settled on SQL. Ironically, none of these things got into commercial use very soon. So, they were doing this work in the early 70s, but nobody was really commercializing it yet. And so it gave Larry Ellison the opportunity to be sort of the first to market with relational database. And so, and
Oh, okay. So Oracle first to
yeah,
market. IBM, it's surprising IBM wasn't, but Jim Gray said that he worked there for like 14 years and they shipped the first line of code that he worked on after he left or something like that.
yeah, I think they moved a little slowly, but Oracle came out in 1970, 1980, 1979 or 1980, somewhere around there. And it was really the
Mm-hmm.
first thing that you could buy for mini computers and mainframes and stuff. And then not long after that, Stonebreaker and colleagues started commercializing Ingress. One sort of weird anecdote about Ingress: I used to know people who pronounced it Ingres,
Like the
like
French
the French
painter.
painter, and because of that, I also knew people who, when Postgres first started becoming popular, people would pronounce it Postgre. So IBM didn't get a database on the market until 1982, which was IBM DB2. So in the 80s, these were kind of the players. There was Oracle, Ingress, and
Ingress,
DB2.
Oracle, DB2. Okay.
Um,
Yeah. And would you say a lot of businesses bought these things or were they widely available in big business? Was it small business didn't use these, big business only?
they were
What's the
they
picture
were
there?
primarily for bigger businesses, and they were primarily, there weren't really people using them that much for software applications. They were,
Mm-hmm.
people would companies would store their data in these things, and then they would run reports on them, and they would get
Mm-hmm.
out reports from the database on what their inventory was or what their sales were. That started to change in the 1980s and 1990s, but really at this point in time, people weren't thinking of them as being the underpinning of applications. Stonebreaker started working on
Oh, yeah. We
Postgres
talked
around
about that. Yeah.
1986. And then in 1989, Microsoft finally came to market
SQL
with a
Server is
SQL
1989. Oh, I would
product.
have thought
They
earlier. Wow. Okay.
The first commercial version of SQL
I guess
Server
that
was
makes sense.
89.
89. Yeah, I guess that makes sense.
And then I don't know how much market they had in the early days, but I think they
Mm-hmm.
were trying to be a business platform. Microsoft was, so
And
they
MySQL,
felt
do you
like
know
they
when
needed
MySQL came
something.
about?
Yeah, so in
Oh,
1995,
wow. So that's earlier than we
MySQL
thought.
came
Go
out,
ahead. Sorry.
and I don't think a
Hmm.
lot of people were using it at that point in time, but this had, to my mind, this was kind of like a profound inflection point in the history of relational databases, because MySQL was effectively an open source product. It was something that people started to use to
Mm.
build into their web applications. It really made the idea of using a relational database as the data layer of your application into being a
Okay. All
much
right.
more
So it's
common
viable, but
thing
then it starts to
from that
become
point
almost like
on.
an obvious design decision.
Yeah, and MySQL, was really sort of the predominant database of
Yeah, by 10 years later,
the web era.
2005, 2010,
The,
somewhere in there, you got all these products, Twitter, GitHub, everything. You got WordPress. It seemed like everybody used MySQL. It just seemed like the thing. When I started using PostgreSQL, I remember it being kind of a almost unconventional and odd choice. People would be like, "Are you sure?" Everybody uses MySQL.
yeah, I think it was sort of considered to be a little bit of a risky choice, even if you're using MySQL to switch to Postgres. But a couple of things happened. I think it was 2008 when Sun bought MySQL, and I think that made people a
Mm-hmm.
little bit nervous that it wasn't going to continue to be an open source, freely available
Mm-hmm.
product.
When I
But
started
then
using
some,
MySQL, it was right in the lee of this, and people were like, "Uh oh, this is going downhill. Better be ready. Find something else."
And a couple of years later, something even worse happened, which was that Oracle bought Sun. And so MySQL suddenly became an Oracle
Yeah, I remember
product.
people like almost panicking at that point, like we need something else.
But it's surprisingly still extremely popular in the web world. And I don't know, but I would guess it's probably one of the main choices for things like Amazon's RDS, probably also the managed services for the other cloud
I'd be
providers.
curious about that. The one of the funny things that showed up in that Stonebreaker interview, I know I keep going back to it, but he seemed to have this take almost that our relational databases were almost like a victim of their own success. Like they're so common, so ubiquitous now that people apply them even in places where it doesn't really even make sense. You've already got this tool, we'll just shove the
Yeah.
stuff in there, right? But then you sort of compound your problems. He had this hilarious example, which you drew my attention to. And then when I read it, I was like, yeah, that is really funny. He's talking about his examples procurement systems. And he's been CTO and advisors for these a couple different companies. And one of the companies they've advised is General Electric, GE. And he said they have, companies have procurement systems which you use to go out and buy things, paper, ink, cartridges, computer, whatever. They have a procurement system. And he said, so it's logically like if you were to think about this, you just picture in your head a company, you think they have a procurement system. How many of those would you imagine they have? You probably imagine they have one of them, right? Like, why would you have more than one? And
Right.
he goes, yeah, so the obvious correct number for procurement systems for any companies to have one. And the interviewer goes, yeah, logically that makes sense. And he goes, well, GE has 75 of these things. It's like, what? What? And he uses that as an example for like the way in which data gets so dividedly used. It may be roughly the same concepts or the same abstractions. The same company sells you ink cartridges, right? They sell Department A ink cartridges, they sell Department B ink cartridges, but Department A and B have like different ways of using this information, different data they want to apply when they make the decision about how many cartridges to buy or whatever. So you get the same data represented in completely different ways, and you end up with 75 procurement systems, which still sounds completely bonkers. So databases, a victim of their own success. Maybe I'm taking the wrong message out from there, but he seemed to be saying we need to be able to break free from the paradigms. Yeah, we've gained a lot from relational databases, but because of we're so reliant on them and we reach for them so commonly, you end up with situations where people have to build their own applications to represent the data in the special way they need to represent it. Did you get the same interpretation from that?
I think so. And I also see this in practice quite a bit. There's this phenomenon I see from time to time where it's like, well, we're using Postgres for this. Shouldn't we just use Postgres for this thing too? And what you end up with is things like Postgres databases that have one
Oh,
field that's a
yeah.
JSON blob, or you have people using Postgres for their online transaction processing, but then they use the same
Data
database for
warehouse,
their
yeah. Data
data
warehousing. They talk a
warehouse.
lot about data science in this interview and the needs of people doing business analytics and data science and data warehousing. And yeah, I could see how you potentially, as a someone who chooses technologies to build business solutions on top of, sometimes there's a little bit of oh, am I picking the wrong thing? Am I closing off the possibilities I may want to exploit in the future? It can be a little nerve wracking when you're right at the beginning of a big project picking technologies because you're not sure what you don't know yet, and you don't want to pick the wrong thing.
It's very difficult also to have sufficient expertise to understand why you might want to choose one
Mm.
database over another database.
That's what you were supposed to answer for me
Um,
here. I was
and
just
I
going
say
to
this
say,
is
Mike says this.
we've encountered this, and I still struggle with it. You know, if you're going to use things like Postgres, MySQL, Oracle are often a great solution. They're very performant. They're very reliable. When you use the managed versions on the cloud providers,
Mm.
you get a lot with that. You know, they do backups for you. They do replication, even
Mm-hmm.
geo replication for you. So they're safe. They're secure. There's sometimes good architectural, good technological reasons for using something else. You may need a database that is much lower latency, and the
Mm-hmm.
latency is an important thing. Whereas maybe
Mm,
consistency is not. There are cases where you need a database that serves as your warehousing system. You need different specifications than what you need for your
yeah.
transaction
The small
processing
organization, though, you start
database.
making things
And
complex by having a lot of different tools to reach for potentially.
and if you tell your bosses we need three databases, you're going to get a lot of pushback unless you can find very good both
Mm.
technological and business reasons
Well, I'll
for
tell you one
why
thing
you
that I
need three
never got
databases.
any expertise on myself, just really, really broad brush stuff. But you remember years ago where people would write these articles like, we were using PostgreSQL for this. I remember Pokemon Go was a big one. They were using PostgreSQL, but they were writing just a massive volume of writes because as people were walking around with the Pokemon Go app on their phone, they were like writing back every place they had been to. So just a huge amount of telemetry going back and getting written into a PostgreSQL table, most of it never being read. So that was one example. I can't remember, there was another really big famous example of some web company, and they were like, yes, we were trying to write large volumes of data in PostgreSQL and it didn't work, so we switched to MySQL with InnoDB. Really makes these writes so much faster because of like index rebuilding. I don't even remember the details, but there were a lot of heated conversation about this maybe 10 years ago, and I myself never really learned all the things I should probably know to pick one or the other.
Yeah, the internet and also Internet of Things has kind of broken databases in a sense, because I think when these things were being developed, people did not think of situations where I'm going to need 10,000 writes per second. It just wasn't really, it was hard to imagine something like, I remember going to a talk by a guy from Pinterest and talking about how they had to process tens of thousands of clicks per second or something like that. And, just, I don't think when people were thinking about accounts and inventories, they really thought
Mhm.
that was ever going to be a
So
likely,
I enjoyed this
likely thing.
conversation. I feel like I learned more about the history of SQL, history of the relational algebra. I want to read this cod paper. And I think the history, the timeline of relational database is a little more solid in my head now. So there's Jim Gray, there's System R, there's IBM with DB2, there's Ingress, and then PostgreSQL, and then a cluster of like SQL Server, MySQL. This is more of a, I guess, 90s. I think it's pretty cool to think about this tool that I use on a day to day basis and sort of see more of the history where it came from. I don't see it being supplanted anytime soon. What about you?
I think I think relational databases are probably here for
Hmm.
a very long time. I saw a couple of projections of how the market's going to grow. To be perfectly fair, in a lot of applications, it's still probably the most sensible way to
All
store
right.
data.
So this has been Picture Me Coding with Eric Aker and Mike Mull. Thanks, Mike. Thanks for the conversation. We will see you
You are
again
welcome.
in 2 weeks. We are going to be bi-weekly. Is that the word I want?
I
Okay, so
think we decided that's
bi-weekly
the right
Picture Me
word,
Coding.
yes.
Thanks so much for joining us. We will see you again soon. Bye-bye.
See you next time.